This video is all about the channel mixer. I'll split it into two parts. In this first part, we'll have a look at the mathematics behind the channel mixer to understand exactly how it works and what we can do with it. And in a second video, we'll take some photos and see how to edit them using what we've learnt. I'm Nicholas, and let's do this together. Let's start with what I found in the documentation of this channel mixer. I have a formula here, red out, green out, blue out equals 3 times 3 matrix times the vector red in, green in, blue in. And we have an initial state that was given. Let's have a look at this formula. So if you're not familiar with matrix multiplications, and you would be forgiven for that, then the multiplication is actually the first line times the vector would be equal to the first value here. The second line, green, would be the second line times the same vector. When I say times, it's a multiplication and an addition. So it's this number times this number plus this one times that one plus this one times that one. So it's a mixture of adding and multiplying. And the third one, I might as well do it blue. The blue out would be this blue line times the same three numbers. Okay, I've written them here because I don't suppose you want to watch me write all those, but we do need them because this is what the channel mixer does. So the channel mixer will use all three channels of an input color, and the input color is every single pixel on the picture. It will mix the red, the green and the blue values of any pixel by the three numbers on this line, and it will calculate an output red. So it's like a machine, if you like, where you pour in a colour and it will give you a new one on the exit with these calculations, and that's what we're going to use. And we find that, if you like, in the Darktable interface. If I go to what do I have? Color calibration. Here, in the color calibration, I have one tab for red, which has red input, green input, blue input, so red in, green in, blue in. That's the first equation, which is vertical, whereas the equation here is horizontal. That's the first equation is actually vertically in the UI. The second equation, so the green output is equal to a mixture of red input, green input, blue input, and the blue output is a mixture of red input, green input and blue input. So let's have a look at this, if you like, and try and see what how to get the channel mixer to do nothing. So if I move those out, the idea would be to find 9 numbers, because there are 3 sliders in each tab, 9 numbers, so that it doesn't do anything. Which means, doesn't do anything means that red in equals red out, green in equals green out, and blue in equals blue out. Well, what would you put in there? If you want red in to be equal to red out, well, we could have 1 times red in is red out, and then 0, 0. And if you calculate that, that is red in. If I put 0, 1, 0, 0 times this is 0, 1 times green in is green in, and 0 times blue in is 0, so what do I have? Green in. And if I put 0, 0, 1, then I have nothing, 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 and 1 times blue in is blue in. So red out is red in, green out is green in, blue out is blue in, and that is the channel mixer doing nothing. And this is exactly what you've got here. That is why the sliders are in that position. When you switch on the color calibration, you have 1, 0, 0. In green, you have 0. Why is it not like that? That was already changed. That was strange. So 1, 0, 0, 0, 1, 0, and 0, 0, 1. And that is the color calibration doing nothing. Well, it does perform CAT, so I can't switch it off. But that is actually no colours being changed by the channel mixer itself. Okay, Next thing, once we've understood what the initial state is and how these calculations work, and I'll leave that like that, let's talk about why I've used 1. Why did I use 1 here? Why didn't I use kind of 2 and 2 and 2? Well, that would be red out is twice as much as red in, so it's redder. Green out is twice as much as green in, that's greener. And blue out is twice as much as blue in, and that's bluer. So what happens when you do that? So if I click here, I put in 2, that's redder. Put 2 in there, that's greener. And this is bluer. So what's it done? It's actually made it brighter. So we have to be careful about luminosity in this channel mixer. Okay, I'll reset that, and just to be careful, I'll make a new instance here, which is in none, which is bypass mode. And when it's in bypass mode, I'm actually only using the channel mixer, and I'm not doing any color adaptation, white balance or anything. So here I have before and after. It's brighter. Why is that? Because the luminosity of a pixel, well, it's calculated using, there are only 3 values for a pixel. Each pixel is only made of red, green and blue. It doesn't have kind of a 4th value, which would be its luminosity. The luminosity depends on how much red, green and blue there is. Now the usual formula would be the square root, this is what they call the Euclidean norm, of red squared plus green squared plus blue squared, but there are many different ways to calculate your luminosity. So it does depend on the 3 values. So if you have more than 1 red or 1 green or 1 blue in the outputs, then the luminosity will get brighter, the pixels get brighter, and if you put less, it'll be not as bright. So the first, I think, lesson we need to learn and remember is keep the sum around 1. The sum in each tab. The sum of each tab around 1. You can actually keep the total sum of everything around 1. If you like, which would kind of keep the luminosities. It's a general thing you need to know. It is rules that we will break because when we get a little bit creative with the colours, then we'll do minor transformations, and maybe the picture will get a little bit lighter or a little bit darker, and maybe we'll have to go back to exposure just to move that a little bit up or down, but it doesn't really matter. That is one thing to keep in mind anyway, at the back of your head, really far at the back of your head. The next thing I'd like to talk about is the channel mixer used as something to swap channels, which is one basic way I learned to use the channel mixer when I started, was for infrared photography. They'd say, yes, you have to swap the red and the blue channels. Well, the channel mixer can do that, they say. Okay, well, if you have a look here, if I want to swap the red and the blues, then all I want to do is say the red out is equal to the blue in, and 0, 0. The green out, I don't want to change that, so I'll put it equal to the green in and 0 out the 2 others. And I say the blue out is equal to the red in, and 0, 0. So in the red column, the red tab, I have 0, 0, 1, and in the blue tab I have 1, 0, 0. And we'll just see, always check if what you're thinking and what you're calculating actually works. I have here a picture which would be useful for that. Red, green and blue. And if I put here red, what's it done? Red, there's been some swapping done here already. 0, 0, 1. I have for that one. Green 0, 1, 0. And blue, what did we say? 1, 0, 0. Now look, I switch it on and off. I'm swapping the red and the blue. and you could swap anything else you liked, and that is useful for infrared photography. So I have a picture here which I have actually used the color calibration on. I've swapped channels. So this is before and this is after, so it's not exactly the swap that I talked about. Here I've used the blue input and I've used that for red. For green I have replaced the green channel by blue, and in the blues I've used the red and the greens and -1 on the blues, and that is another kind of recipe I had to try and get some colours out of an infrared photo. So there we are, and I have respected the idea that the sum of each column is 1, so 1 + 1 - 1 is equal to 1, and here we have 1 and there we have 1. So that is a second use of the channel mixer, and the more we use it, then the better we understand exactly how it works, and the quicker we'll approach more subtle transformations. Let's go to the third example, which is monochrome, black and whites if you like, monochrome photos. Can I use the channel mixer to get monochromes? Well, the answer is yes. Probably know that already. How does it work? Well, a monochrome photo is achieved when all three output colours are equal. So there's as much red, green and blue in the output. So what I want here is to have 3 equal numbers, and there are many ways to do that. One easy way to do it is to take, in the red output, 1 times the red in, and I don't take any notice of the green and blue. For the green, so this is red in. For the green output I do the same thing. 1 times red in plus 0 is red in. And the blue output I take 1 times red in, 0, and I have red in. And that theoretically should be a monochrome. Let's go and see. Should I take maybe the take that tower again, color calibration here, we'll move that to re-initialize everything. This one, so I'm in bypass, so I'm just in the channel mixer mode. 1 0 0, and we have 1 0 0. Don't forget my equations are vertical here, and 1 0 0. Yippee! And monochrome. So color monochrome. And what am I doing? Well, I'm using the red inputs to get the colours. This is exactly the same thing. This is what the grey tab is for. Is if I put the red input to 1, I have the red monochrome, which is exactly the same as copying the 3 same equations into the 3 tabs. Because monochrome is that, it's 3 equal equations into each of the 3 red, green and blue outputs. If I put, let's say, green at 0.5 and red at 1, take a snapshot of that, and then I restart that and put 0.5 here, and then copy the same equation, 1 0.5, and here 1 0.5, and put this to 0, then I get a monochrome as well, which is the exact same one as when I use the grey tab, and it's brighter. We know it's brighter. We know it's brighter than the original photo because the sum of the coefficients is 1.5. Now, does that matter? Well, not really. Not here. So that is the third use of the channel mixer. Now, the last thing I'd like to show in today's video is how to change one colour into another. Completely change. I mean, not even a close change. So let's erase these formulas. I can erase the whole lot actually. Let's get rid of that. And let's put the multiplications and see what we can do with this. So the idea is to go into Darktable here. I've got a photo with some blobs. and blobs of colour, and I have a purple here which I'd like to change into this green here, and I have the white, red primary, green primary and blue primary, just to see what byproducts we'll get of this transformation. I have already, with the colour picker, set one picker on the green and one on the purple. I have blocked them, and that's thanks to a comment I had in the previous video that you can actually click on these to block them, so that when let's see if I do something here, we change the colours. We've lost dark table. No, it's come back. So anytime you change colours, these live samples will update, but I'll just reset that. If I click on them and get the little padlock, then any change I make will change obviously the picture, but won't change the samples. So I want to change this purple 84, 84, 140 into a green 62, 141, 164. So the input is the purple and the output is the green. So the input 84, 84, 140. So the red input is 84. I'll write that 3 times. The green input is 84 as well. And the blue input is 140. 140, 140, 140. And the output, which is what I want to obtain after the mix, is the green 62, 141, 64. 62, 141, 64. And now the problem is to find, I'll take this pen, 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers that will actually compute correctly, so that each of the 3 calculations gives the 3 numbers that I want. Now I'd like to state that in maths, when you have 3 equations with 9 unknowns, there is an infinite number of solutions, and that maybe is the first takeaway point. So there are an infinite number of solutions to each change in colour. So we're going to have to work with that. We've seen that by using simple coefficients we can do some transformations. We're going to have to find some more subtle transformations that, and we have an infinite number of ways to do that. And we will have a third takeaway point soon. That's pretty. Oh no. Okay, got it back. So how can I do this? Well, as usual, when I'm confronted with a maths problem, I try and find. Sorry, this pen is going all over the place. Terrible. There. I try and find something easy to do. Usually, when I have a lot of coefficients, is just stick as many zeros as I can. So imagine, let's remember some simple fraction mathematics. 62 is how much times 84? Well, it's actually the fraction 62 over 84. 62 over 84 times 84 equals 62. So I already have 62, and I can put 0 here and 0 there. So I'm using the red component for the red. Why? Because it seems like a good idea. And I'll try and use the green component. I could actually not do this. It would work. Just to show that there's a little bit of logic behind what I'm doing. I'm going to use, so for the greens, if I want 141, starting with a green of 84, I'll do 141 over 84 and 0 out the 2 others. I could actually put this number here and the output would be exactly the same, and I could put it, well, I could use it here, but I'd have to put 141 over 140 if I did it here, and then the answer would be 141, 0 here and 0 there. So you can actually do it everywhere. but just to keep some kind of logic, if you like, or some kind of relation between the colours. Here I want 64, I have 140, so 64 over 140 times 140 is 64. So those three equations compute out correctly, and the purple should turn green. Let's go here. So now they're locked. I can actually input the equations and not use, what I used was a little text file in the previous video, which I absolutely don't need. So 62 over 84, you can just read the numbers on the left, 62 over 84. In the second one I have 141 over 84, and in the third tab, in the blue equation, I have 64 over 140. 64 over 140. And that here, I know it looks blue, but it's a green. And let's unlock these patches, and I have now this colour that was previously purple is 62 141 64, which is the exact same green as this one. So that's how it's a possible way of making it work. There are an infinite number of solutions. What you need to do is be careful of what happens to the other colours. I've kept the red and blue primaries more or less intact, but the white balance has completely gone, and now everything's green. I did try some other ways to do it. What did I try? I tried a direct rotation between the colours. This one looks really blue now. It is actually the correct green, 62, 140, 64 here, which just goes to show how much the eye adapts not only to what you're seeing but what is actually around what you're seeing. There's always, the brain is working out relations between things. So that's another way. That is a direct rotation between two vectors, which I had fun doing. And look at the coefficients there, they're kind of a little bit all over the place, a little bit of this, a little bit of that. You wouldn't find that just by trial and error. I tried to do a rotation and keep the white balance. So here's before and here's after. So I have got a green. It's not exactly the same one. It's the closest you can mathematically get just by a direct rotation. As far as I could work it out. So it's not exactly the same, but the advantage of this is I keep the white, even though I do lose the primaries. So if you look at the numbers on the sliders here, they are all over the place too. So mathematically there are many ways to find the colour you want from any. You can change any colour into any other colour, and there's an infinite way of doing it. The thing you need to remember is it will have an influence on all the other colours, and that is the third takeaway point here, is keep an eye on what is happening to the other colours. Pen's getting sticky. Okay, and the last point I'd like to state, this is just something that is just mathematical truth, is that in this formula here, which is the original matrix, we have a multiplication between a number on the slider and the red input. Then we multiply the number on the slider by the green input and the number on the slider times the blue input, and then we add all three values. The slider doesn't have more influence on the output than the actual colour you had originally. In a multiplication, then both partners are equal in effect. There's not one which will have more effect on the other. So the input colour is just as important as the slider, and we need to remember that. The input colour is just, it's sticky, sorry, as important as the slider, and that is just a mathematical truth. so that when we do the colour changes in the next video, not only will we concentrate on the sliders, but we'll also have a long hard look at the input colours. So that's it for this first video on the channel mixer. It was a bit technical, but I think that we've laid the foundations now to edit photos with more subtle changes. Okay, we'll see you soon then. Take care.